So last lesson, this is about chapter 5.2 mechanics year 2. Last lesson, we were looking into forces and friction about, normal plane, a flat plane. So what we did was we actually learned how to resolve the forces, and then we look at the forces on the horizontal plane to see how they interact with each other. So remember this diagram about one is pulling in the other. So what we have to do is we have to resolve any diagonal forces. So by resolving, it means we draw a right angle triangle on the x-axis, and then we can use trigonometry to work out these two. Once we've resolved all the forces, we put them into a force diagram. A force diagram essentially is just putting the diagonal forces, the resolved forces that we found, into x and y axes. And then after that, we can do some calculation on see who's the winner on the x-axis. So you can see 2 is bigger, so 2 minus root 2. So we've got 0.586. And for the y-axis, because they're both shooting upwards, so we add them together because they're on the same side. You don't want to fight against your allies, don't you? So root 2 plus 2 root 3 is 4.88, right? So today, what we're going to do is we're doing on the inclined plane. Now, inclined plane is a sort of a big one because you need it for chapter 7, especially when you play along with the pulleys as well. It's not a favorite word a lot of people like, but pulleys is a big one in chapter 7. So before we start, so first of all, in the notes, I think you've got a whole page of notes. Now, to begin with, we've got a horizontal plane. So on a horizontal plane, your x and y axis are normal. Okay, so that's your x and y, right? But for inclined plane, your x and y axis will become like this. So that's your x and that's your y. And what this is the slope, okay, of the inclined plane. So basically that's the plane. So you might have objects sliding down along the hill, and that's the inclined plane, that's the slope. All right. So anything that is not on the x, so remember, any forces that are not on the x or y axis need to be resolved. So like last time, when the force going like this, for example, then you have to resolve it into x and y. Same in here. If you have an axis like this, have a force pointing upwards, pointing diagonal, not along the x and y, you will have to resolve it. All right. So next, for example, right, a small example, just draw in here, e.g. Right. So in here on an inclined plane, that's an inclined plane. Let's call it theta. Right. Let's say we're standing on there. Right. Now, when you're standing on a slope on a hill, do you know how does the gravity work on you? Now, remember, gravity always pointing directly towards the core of the Earth. In other words, it's always directly downwards. Now, however, there's an inclined plane, isn't it? If it's an inclined plane, look at what I said about the axes. The axes will be in an angle. So the axis, if you have a pencil, this is what I would suggest you do. Okay, if you have a pencil, there's going to be an axis. That's your x, and that's your y. So in other words, what it means is we do have to resolve the mg. Now, why? Because mg is not on the x or y axis. So it has to be resolved. So by resolving means putting back in the x and y direction. So now this is not going to be easy, but good thing is you don't have to remember doing this thing again in the exam. I will give you a shortcut later. But as a math lesson, we do have to go through the difficult maths in between. Now imagine that's a particle. Okay, so that's a particle u. So that's your mg. That's the x, and that's the y. Now we've got our theta in here. So if I use parallel lines, I can make another parallel line like this. It's a theta, right? Now, if I want to make along the x and y axis, all I need to do is is, imagine I just rotate it around. So if I rotate it and make the X and Y normal, so rotate it, okay? So what will happen is, if I rotate it, then the theta will be like this, wouldn't it? That would be a theta. And then that would be a theta, right? And what's your mg? Your mg will be right here. So I rotate it a little bit. Now, what I can do is now I can make the connection with the X and Y axis. So if I make the X and Y axis like this, or if you prefer like this, doesn't matter. Actually, let me do it this way. Right, now, we have the angle and a theta, but the theta is not directly on the triangle that we need. This is the triangle that we want. So how do we work out the angle inside a triangle then? You know, it's not going to be straightforward, as you can imagine. First of all, what we know is, we know this is the right angle. If that's a right angle, yep, that's going to be a right angle. This is going to be 90 degrees minus theta. Now, what we also know is, we also know this is also right angle. So this angle here is going to be 90 degrees minus 90 degrees minus theta, minus 90 minus 9 is 90 minus 90 is 0, minus makes a plus, so that angle is theta. So what I wrote in red is the first step. If you want to have a sequence of working out, second step is theta. So let me draw the triangle out again. So this, I'm drawing triangle out. This is the mg. Your y will be going down, your x will be going left, because if mg is going bottom left, ultimately, then you have to have a y going down and x going left, and that's your angle theta. So if I use some trigonometry, I can use sine theta equals x over mg. So multiply mg over, so x equals mg sine theta, and y will be mg cos theta. So what does that mean? Well, after all this difficult calculation, what it means is, when you're standing on the hill, now if the hill is too steep, if the slope is too steep, you will roll down like a snowball, right? No one wants to happen. But when do you know if the hill is too steep? So what calculation is pulling you down? Is, we know the heavier you are, the more likely you're going to roll down the hill. But why? Because we know the gravity. So the exact value that is pulling you down is the mg sine theta in here. So after this, what we have is your mg that was, sorry, your mg that was here. Now it has been resolved into the mg sine theta, going down and going downwards in a y direction. Remember, the axis on the slope is tilted, it's an angle like this, so that will be mg cos theta. So what am I trying to say in here? So here's a shortcut. Okay, so here's what you have to remember. So these are the forces. So what do I call the fundamental forces. So the fundamental forces acting on a body on an inclined plane. So on an inclined plane, essentially what happens is, if you have a box of m kilogram, you would have to put in mg, and that's theta, cos theta. Mg sine theta is always downwards because gravity is always pulling you downwards, make you roll down. It's not a nice guy, is it? And you also have reaction against it because the floor is still providing you reaction, providing you support. So these three are the very important forces that you have to remember when you see inclined plane. So when you see inclined plane, these are the first three forces you're going to put in there. Same direction, always the same, right? If you have a pencil, what you can also do is you can draw a line x and y axis like this. So the good thing about remembering these three forces is, now look at these three forces, they're all in line with the x and y axis. If they're in line, that means you don't have to resolve. So it's always there. So these three forces are always there. So draw these three forces on an inclined plane. Always. I mean, grammatically it's not correct, but who cares, right? Maths is maths, English and English. We don't get English anyway. Right. So that's what would come out from the whole notes thing. It's quite difficult to some people, especially some physicists. They like to resolve it every time, but the resolving process for the inclined plane is not easy, as I said. So what I would tend to do is I tend to just remember mg sine theta going down, mg cos theta in the y, and r opposite. Right, let's have a look how we can apply it into the example. A particle of mass 10 kilograms slides downwards from a rest at an angle alpha, where 10 alpha equals 3/4. So here's a slope. We've got a particle of mass 10 kilogram. That's alpha. Now we don't care what's going on. What we do is, first of all, we have got 10g cos alpha in here and 10g sine alpha and reaction. That's the staple forces. These are the fundamental forces that are always on there. Okay. Anything else? There's nothing else we have to put in there because there's no friction, nothing else. So if they didn't mention anything, these are the forces you have to put in there. Find the acceleration of the particle. So this parcel is sliding downwards in an acceleration. So what do we do? Well, first step, like before, do we have to resolve any force? So resolve any force. The answer to this is no, because all forces are on the axis. So where the axis, okay, if you want to use a pencil, you can, like what I mean, that's your axis. Yeah, so that's your axis, that's your x and y. They're all on the axis, x and y like this. Next step, you can draw a force diagram if you want to. Now this is going to be quite useless in this question for now because you could draw the axes. So we've got 10g sine alpha in here. We've got reaction and we've got 10g cos alpha. Right. Now, where is the acceleration pointing? The acceleration, step 3, the acceleration is on the x-axis. So we use F equals ma on the x direction. So on the x-axis, we only have 10g sine alpha. So we're not using anything up on the y-axis because as I said, part A, acceleration is acting along x-axis. So therefore, when we do F equals ma, only on x-axis. So 10g sine alpha equals the mass 10 times acceleration 10a. So what's sine alpha then? Well, what you can do is you can work out using 10 alpha equals 3/4. So on the side here, so 10 alpha equals 3/4. So alpha equals inverse 10 of 3/4. Now, there's one thing I have to say here using a calculator. Now, when you use inverse 10 of 3/4, so inverse 10 bracket of 3/4, first of all, make sure your degree is in degrees, not in radians. And then you put a bracket. Now, alpha equals 36.86. You see it's not a nice number. So what I do is I write 36.9 degree. Then I'm going to store it in the calculator because if I don't store it in the calculator, if I don't use the full value, I know I'm going to make a mistake. I'm going to make some rounding error. Now, it depends on your mode of a calculator. If you don't have the same one as I do, just ask me in lesson when you see me how to store in the calculator. In the time being, you can always rely on using inverse 10 of 3/4 type in every time. So in the calculator, what I'll do is, can you see STO in here? Now these letters A, B, C, D, E, F, X, Y, and M, these red letters, they're not there to type in your name. Okay, now every student does it every single year. And as a kid as well, I would do that. I try to make my name using these little funky letters. But no, these are memory boxes. You can store each value in the memory in a box and you can retrieve them later. So in here, let's say I want to store this value, so I press STO. And then if I want to store in A, I just press this button underneath A. So you can see answer to A. Now, some calculator will have the STO on the yellow thing. So what you do is, instead of just pressing STO, you press Shift, that button, which give you STO, store, and then click same thing, A. You should see the same line at answer to A. So now if I press AC, so if I press alpha, that one, so if I actually press A equal, you see I get that 36.9. Okay, so that's how we store a value. So what I'll do in here is I can do 10g times sine alpha. So you can I'm going to put it in a calculator. 10 times 9.8 times sine. I'm not going to put alpha in, I'm going to put sine A equals 58.8. Now, if you don't use the full value, you won't get a clean value like I do, 58.8. So 58.8 equals 10A divided by 10, 5.88 meter per second squared. That's the answer. Part B, find distance. What do you think? Distance after finding acceleration? It's a good friend, Suvat. To find the distance, that's the same as work out S. We know acceleration is 5.88. In the first 2 seconds, so t is 2. So what do they want us to find? They want us to find distance. Okay, they told us it's sliding from rest. So slide from rest means u is 0 from rest. So hopefully you remember these formula. They are given in the formula booklet. So you're going to use S equals ut plus half at squared. So S equals 0 times t plus a half times 5.88 times 2 squared, which if you put it in calculator, you'll get S equals 11.76 meters. Sorry, my thing got disconnected. Okay, so S equals ut. Yep. So where was I again? Yep. Sorry. So if you remember them, so S equals ut plus a half at squared. So S equals 0 plus a half times 5.88 times 2 squared. If you plug in calculator, you should get 11.76 meters, which is the final answer. Okay, so one more example. Let's go. Example. So a box of mass 2 kilograms pushed up on a smooth plane by a horizontal force of magnitude of 25 Newton. The plane is inclined to the horizontal angle and an angle of 10 degrees. Find the reaction force of the box. So first of all, let's draw a diagram. So we know all the forces on there. So we've got 2 kilograms. As I've told you, the 3 forces, 2g cos 10, 2g sine 10, and reaction. Now, but this time we also have a 25 Newton pushing in. So if you have your pencil, you will notice 25 Newton is not on the axis. So 25 Newton is not on the axis, what do? Step 1, resolve 25 Newton. So what we can do is we can just draw an axis, but with the 25 Newton, just the 25 Newton singular out, deserve some punishment, 25 Newton. So that's your X, that's your Y. So we can draw the axis like this. We can draw a triangle like that. So using parallel lines, that's 10 degree, right? So 10 degree using parallel lines, that's 10 degree. So using a parallel angle. Now, maybe you can tell me which direction is the X and which direction is the Y. Now, 25 Newton going right. So that's your Y axis because that's parallel to Y. So it must be going down. And for X, it must be going up. Because of a 25 Newton going to right direction, you must go down and go up next. Right? So let's do trigonometry. So for the X value, that's adjacent of cos. So 25 cos 10 degree. And you can put in a calculator, 25 cos 10 would be an unknown value. So actually I'll leave it like this. So Y will be 25 sine 10 degree. The reason I don't put it in a calculator is because they're not exact value. So you can use a calculator, store button value, store function again, store into A, B, C, and D. But for now, I'll just keep it as is. Step 2, force diagram. So force diagram, I'm going to draw a big force diagram, your X and my Y. So my X is 20G, is 2G sine 10. That's a set life, that's my X. 2G sine 10, and my Y, like the word like a wife, I don't have a wife, but like a wife, my wife is going down, is I've got 2G cos 10 in there, and I've got reaction going upwards. Next, what I also have is these two from step 1. My 2G cos 10 pointing, look at X going upwards, so I'm going to put 25 cos 10 degree, 25 cos 10, and for Y is going downwards, 25 sine 10. Okay. Right, so what's next then? Next, I'm going to use F equals MA, step 3. They want to find the reaction. So I'm going to use F equals MA on the y-axis. So on the y-axis, on the y-axis. So the y-axis, now, is there acceleration? There is none. Now, before we do that, what's the resultant force? So it's the upward force, take away downwards force. So 25 sine 10. So my laptop is a bit low in battery. That's why it's, you can see it's reacting a bit slower. 10 degree equals the mass, which is 2 times 0. Now, why is it 0 in here? Because no acceleration, sorry about the writing, no acceleration on the y-axis. Now, the box is moving left and right. It is not moving up and down. It's not ghost. It's not moving up and down. So no acceleration on the y-axis. If there's no acceleration on the y-axis, the acceleration is 0. So if you plug in a calculator, so before I do that, if I move 25 sine 10 and 2g cos 10 to right hand side, so R would equal to 25 sine 10 plus 2g cos 10. So put in a calculator, you should be able to get 23.6. So just let me double check quickly. So 25 sine 10 plus 2 times 9.8 cos 10 is 23.6. So reaction is 23.6 Newton. Right. Part B, find the acceleration of the box. To find acceleration, we know acceleration is acting along the y-axis, x-axis. So part B, so we use this time F equals MA on the x-axis. So F equals MA on the x-axis. Which way is the box going? The box is pushing up, being pushed up. So therefore, the force going upwards must be bigger than downwards. Now we talk about X, so we just look at the forces on X. So the box being pushed up, that means the upward force on X must be bigger and greater than the bottom, so that it's going up. If the downward force is bigger than the upward force, then the box will be sliding down. So the force going upwards, so the resultant force will be the bigger force, 25 cos 10, subtract downward force, 2g sine 10, which equal the mass, which is 2 times acceleration. Okay, so we'll put in a calculator, 25 cos 10 minus 2 times 9.8 sine 10 divided by 2. So I got acceleration equals 10.6 meter per second squared. Again, apologies to my writing because my laptop is running low on battery. So yeah, is that it? I think that's 5.2. Yes, so that's 5.2. Okay, so 5.2, what you've learned today is 3 steps. Again, resolve any forces that are not on the axis. Or actually, there's a pre-step, which is to put in R, mg cos 10, mg sine 10. Resolve any forces that are not on the axis. Do a force diagram to put in all the forces in the right position, in the right place, facing the right direction on the x and y. Third step, usually is F equals MA in y direction and F equals MA in x direction. So it's usually both directions. You have to do calculation both. Sometimes you can get away with just working out one. Like the first example in here, we did not have to work out the F equals MA in the y direction because they did not ask us about reaction. But the third step essentially is work out F equals MA in x and y. All right. So we'll be using this type of steps throughout the whole chapter 5 and chapter 7. So in the beginning, I understand it might be quite difficult for you to understand what's going on, but you'll get fluent just like you did in moments. You had your moments, it will come to you naturally and spontaneously, not pun intended. But okay, so right, so that's chapter 5.2.